I would like to talk about data pipelines. And data pipelines is not a very, I don't know how to say it. I mean, I've done a lot of talks, and I've done a lot of talks on different topics, mostly Java related in one way or another, mostly quite a bit Java related. And this one is going to be as well. But then it happened some years ago when I realized I had a problem, I needed a solution. So I tried to solve it. I tried to learn things while I solved it. And I tried to kind of spread the knowledge further on. So this is how this talk came to, And with this talk, I have a few kind of objectives, if you can call it that. One of them, obviously, I want to teach you about this open source tool that I'll be talking about in a second, but also, and I'll give you an introduction of what data pipelines are, how to work with them, or at least one way of working with them, and things like that, and give you like more of a introductory level kind of talk. But there is another kind of a bit more hidden gem in this talk, and that is I would like to encourage everyone and every one of you to try to solve problems that you might have because I mean, all of us, we do work with IT, we can do some kind of programming, to some extent, some different things, and then we can use that things to solve our own problems. And then to use that problems as a, I don't know, I should probably say an excuse in quotes to learn new stuff. And then after doing that, I would like also you to encourage you to actually talk about that and share that things that you've learned. So this is what I'm going to be doing with you today. So let's get into the talk. So one more thing. Please use the chat to ask questions, to comment, to do anything. I have the chat window open right in front of me, so I'll see the questions. I'll try to follow them up as soon as they come in, or at the appropriate times. So feel free. I mean, I don't want this to be a broadcast. I want it to be kind of an interactive thing, right? All right, let's get started. So it's your lunchtime. I hope you're having a really nice lunch here in Norway. It's kind of late. It's getting quite late now. It's 7 p.m. now. So without any further ado, let's get started. I kind of would like to start by asking a question to my little friend here and say, hey Google, what's the bike availability next to me right now? Let's see if it works.
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
Okay, it worked. This is a bit of a kind of the showing off the final product, or kind of the visual situation where we want to go now. And that was the solution to the problem that I'll be talking about now. And to do that, we need to kind of rewind a tiny little bit and to explain you the context and what we were trying actually to solve. I was trying to solve. So if we hit the rewind button and go back, and these are the bikes that I'm talking about. So this is bikes that you probably have seen. I don't remember seeing anything like that in Chicago, but I'm pretty sure there should be something like that. I've seen those in San Francisco. So I mean, the blue ones you see on the right is from Oslo. The red ones you see on the left are from, I think I saw those when I was for DevOps Belgium just before Corona. So it doesn't matter. But the point is, it's a kind of a public or semi-public service where you can rent bicycles. You buy some kind of membership, and then you can pick a bicycle, go somewhere wherever you want, and leave the bicycle. And the way it works, at least here in Oslo, where I live, is that you buy a membership. You can buy a membership for a year, for a season, for half a year, for a month, or something like that. And then you can just use it as much as you want. At least one of the models they have. And usually the way they advertise it, they show really nice pictures of it. This is, I was talking to the people responsible for that. And I was like, look, I need some pictures to use in the slides because I'm going to be talking about this. So do you have any pictures? So they gave me some really, really glossy advertisement pictures like this and like this. And it's beautiful, right? You have this bicycle, it's summer, it's nice weather, and it's it's amazing. Now, the thing is that, well, Norway is not always like that. So sometimes it might be like this, and then it might be a little bit more challenging to bike and everything. So that's why you might not be able to use it for the whole year round if your bicycle is not kind of made for that and everything. But that's not the point. Again, the point is that we have this amazing service and it's pretty cheap to get that. So my idea was, oh, well, then I don't have to drag around my own bicycle from place to place, and I can just don't think about it being stolen or anything like that. So, I can just use that service. And this is the advertisement. So this is like the ad, this big billboard thing, and next to it says it's spring, tra-la-la, spring. So, it's more like the start of the season. This is what they want. This is how they want you to think of it, saying like, look, there's a lot of bicycles. You can just pick one, go wherever you want. It's beautiful. And you come back and everything. And well, to some extent it is like that. But the problem was that by the time you actually want to go somewhere and you've seen all those amazing pictures and you're, really ready to get going, and you expect those places where they're parked, so there's kind of slots where they put them, to be full of bicycles and full of, empty slots, so you can actually park the bicycle when you're done, wherever you come and everything. And this is what you expect to see. So this is an actual picture. I took that picture myself. This is a picture from just outside across the street from my work. And well, this is what you expect to see. What actually happened, and this is kind of, I pass this place all the time. So most of the time it does not look like that. Most of the time it actually looked more like this. So, I mean, it's exactly the same, this parking slot thingy, just it's very hard to see it because there are no bicycles. And this is just from a tiny little bit different angle. So if you replace the angle, so this is what I saw first, and then this is what I saw a few minutes later. So now you're kind of getting this idea of what the problem was. So the problem is that you get a little bit sad because you've been planning to get this, to use this service. So you didn't bring your own bicycle. Your own bicycle is safely locked somewhere, and then you come to this locking thing, this locker thing, and there are no bicycles, or there are bicycles and you picked one, and then you come to another place where you're supposed to your destination, and there are all of the slots are full, so there is no way to put it into this thing, and then you get like fines and everything, not for not returning it in time, and all those kind of things. And then you get a little bit sad, and but then you realize that wait a second, I actually know this thing called IT. So I do work, I do I do this for work, I do this for living, so maybe I can use some kind of some of my skills to solve this problem. And to explain you a little bit of the way I kind of approach this thing, I want to share a little bit of my, what should I call it, a train of thought, or, master plan. I kind of call it very humbly before master plan. So the way I thought about it, I was like, okay, fine, look, we have a problem. There are no bikes, so that sucks. What we can do about that? Well, I mean, I don't know what I can do about that. Do I know where I can find a bicycle? Well, not really, because can I use an app? Well, obviously they have an app. Obviously there is an app showing me where the locations of those stops for bicycles are. And they also show me the amount of available bicycles there. But the problem is that app is nice and everything, but it shows you the exact now picture of that stop. So if the stop is like 2 minutes walk from your house or where you are, you don't really know what's going to happen within those 2 minutes. So you check it. Oh, there's 2 bicycles available. Great. And then you go running there, and then you realize that somebody else picked up your stuff, like your bicycle, the one that you actually saw there, and there are no bicycles. And then you're in trouble again, right? There is also a public API that was actually I was using at the end. I ended up using at the end. But the thing is, again, public API is using exactly the same or showing you exactly the same data as you can see in an app. So now picture, now situation of the stops, and you have to query it. You'll get a number of available bicycles, and then you kind of have to hope that nobody picked it up by the time you sprint to that place. And so that kind of sucks a little bit. So you obviously can do that, but if on the rush hour periods where everybody's using those bicycles, then it's a bit challenging, right? Okay, so then, since I don't have historical data, and I know that I can use historical data for fun things, I thought that, okay, fine, yes, okay, I can probably collect that historical data myself, from the API, the real-time API. I can hoard data, basically, store it somewhere, and do something with it. And then, then you start realizing that, hey, maybe this will be a good solution. So then you start thinking, after this kind of the first wave of euphoria kind of washes over you and kind of passes over you, then you start realizing, like, wait, how do I do that thing? I mean, I work with enterprise customers and stuff, and we're used with building data warehouses and, cubes and stuff, and, putting gigabytes and terabytes of data and using super expensive, fancy software to do all that stuff. Do I really want to do the same kind of exercise for my tiny little bike project? I mean, it will probably be less expensive buying a bicycle every time I have to use it and leaving it on the street instead of just, running all those servers and software and everything at home. I always dreamt of having like racks of servers at home, but probably I'm not sure if the rest of the family might share my passion about that. So I kind of left that unexplored for now. So the solution, right? So I wanted to have a good solution for that kind of thing. The kind of the simplest hacky version of that is to actually hack something together, just to write a script to something and let it do the job. Well, obviously you can do that, and it will probably work for some time, but I wanted to have something robust, and I wanted to learn something. So I've been told about this thing. So I was kind of looking for, okay, maybe I can use this. No, well, that doesn't work. Maybe I can use this, and so on and so on. So I didn't want to have this hacky solution with just scripts. I didn't want to go all enterprise solution because, again, this is not the same dimensions for things. It's not, I don't really have a yearly budget to support all that, and all those kind of things. Flexible, portable, open source, yeah, that would be nice. Is there anything? And then I talked to a friend of mine, and then he mentioned me like, hey, look, there is this thing called something. I'll explain you what it is in a second. You probably have seen it in the description of the talk anyway, so a little bit of spoiler. But then I kind of thought there's, okay, then I can actually solve 2 problems at the same time. I can learn something new, and I can try to solve my problem of, working around this lack of bicycles problem. All right. A few words about myself, just a very, very few words about myself. My name is Rustam. I live and work in Norway, Oslo. I work for a company called Compitas as a consultant. I've been doing it for quite some time. Most of the time, more or less all the time, I work with Java. I work quite a bit with cloud and architecture and large systems and stuff like that. In addition to that, I'm a Google developer expert for cloud. I do talk quite a bit of cloud stuff, serverless, all those kind of things. And I'm also one of the Java champions as well. So enough about me. Back to this thing that we are trying to solve. So the first solution would have been, remember, we have a public API that gives me data. So the first solution would have been to, and actually this is what I ended up doing. I ended up putting all onto a Raspberry Pi, sitting on my desk in my living room, right by the TV and everything, and let it do all the jobs. So this was kind of the big picture, slightly Lambda-ish architecture. I mean, it wasn't a Raspberry Pi, but it was, you know, it was some kind of functions. You can call it a function anyway. It's like kind of ish, but you know, it did the job. So then it was kind of the idea was, okay, fine, I'll create some kind of cron job, something timed that will pull the data every so and so many minutes. I'll put it into some kind of file system. Well, obviously, since it's Raspberry Pi, it's running on some flavor of Linux, so I can just store it on the disk, on the memory, in the memory, and then I use something, so like Apache Spark or something, to process all that, so create a pipeline, put it into some kind of data warehouse, some kind of database, Postgres, whatever, you know, store it in something and visualize it. So that was kind of the first slightly not hacky approach, which was still hacky and still kind of nasty, but it was kind of, you know, well, it wasn't nasty, but it was a little bit shaky though. And then I was thinking that, okay, fine, well, this is a file processing thing, but what if I have a streams of data? If I have, I don't know, streams of weather data, or if they start streaming or something, how do I do that? Well, you know, or, you know, in your case, if you're trying to solve something like that and your API is actually stream of data, oh, well, you can do pretty much the same thing. You put it into some kind of something that can, you know, receives those streams and put that in a queue of some kind, process it in one way or another, again, put it into data warehouse, and then visualize it somehow. But then I wanted to be able to do both. So this was, now I was kind of getting a bit into the over-engineering phase, because, I mean, well, let's admit, at least I have to admit, I mean, I sometimes love over-engineering things, and I probably am not the only one that has sinned in that way, right? But, you know, so then I thought, it was like, okay, can we do something that can do different pipelines, but, you know, it can do different ways of input. So it can be batch files, like in this case, basically big chunks of JSON, or streams, and put it all in one box, black box, white box, whatever, it doesn't matter, churn it in one way or another, and actually produce the output I want. So kind of create this reporting data warehouse solution where you end up denormalizing a lot of data. You kind of probably repeat a lot of data, but it will be much easier to report on that, to generate the statistics and trends and things like that. Well, Apache Beam, that was the tool that I realized that I could use for all that, and that could handle both of those things. And the cool thing with Apache Beam was that, well, one thing is it's an open source product, and it supports all this data pipeline things. And talking about data pipelines, like I said in the beginning, is probably not the most exciting thing. It's kind of hard to build a talk talking about data pipeline. If I would told you, like, look, I'm gonna, you know, talk for an hour about data pipelines, well, most of the people would be like, oh yeah, okay. Well, maybe I'll do something else. But here you're actually trying to solve a bit fun problem and learning how to work with data pipelines at the same time. So the cool thing with Apache Beam was that, as you probably can imagine, since I was building up to that quite obvious, in a quite obvious manner. So, well, obviously you can do both batch and streaming processing, which was really nice for my over-engineering needs. It had a bunch of SDKs, so you could develop things in Go, Python, Java. I chose, well, you can guess which one I chose. I ended up using Java, but you know, you could use all the other ones. And the cool thing is that they have this model that where you build a pipeline, but then you can build, you can add, or kind of add to your pipeline connectors that that can run on different environment. So it can be a local environment, it can be cloud, it can be one way or another, but it also connectors with respect to where you pull the data from. So it can be, I don't know, something that can talk to Apache Spark, something that can talk to Flink, something that can talk to some kind of storage buckets and stuff like that. So that was a very, very nice thing. So this was kind of the idea and the motivation of how to replace those enterprise and big, heavy solutions doing data pipelines with ETL jobs and all those kind of things, to replace that with something that is, it's a big, advanced and fancy product, but it is an open source product. So that's kind of cool, right? So this is the part of swapping out the components. Actually, the other aspect of swapping out the components is that those connectors can be swapped out to be something else. So you can start with, say, a bucket on some kind of cloud provider, but then you can replace it with Kafka, or you can switch it to Hadoop, or you can switch it to something else. And you can do both. You can do both sub kind of queues. You can do Kafka queues. You can do just file system in one way or another. So buckets. So as S3, as Google Cloud Storage, and all those kind of things. And that is really, really nice because you can actually on the fly switch and choose between different ones. I'll show you in a second an example of that on our bicycle examples as well. So back to this a little bit of this picture thing. So like I mentioned, this was the setup I ended up using on my Raspberry Pi, and that was fine until I realized that, well, I kind of knew that, but I didn't think about that. But anyway, thing is, Raspberry Pis run on SD cards. SD cards are not really made to be a file system kind of disk kind of thing, to be written and read all the time, kind of vigorously, many, many times a day. So what happened was that after a few months, the Raspberry Pi went to kind of better places. So it was no more. I mean, it was still there. It was blinking at me happily, but there was nothing on the disk. There was nothing to boot from. There was nothing and everything. So my SD card just died, basically. So that kind of sucked. And then I think I was smart enough to do backups sometimes. Not all the time, sometimes. So I had a little bit of data. So I lost some of it. So that kind of, meh. What I thought to do afterwards is to kind of create a managed version. So then I realized that maybe I can move it to the cloud and see how much that will be and how expensive or how will it work. And I don't have to have that Raspberry Pi thing. So I ended up moving to Google Cloud. And I'll also explain why I chose that. But technically, you could more or less use the same recipe and move it to any other cloud as well. So this is not a sales pitch for a specific cloud or anything, but the examples and things I'll be showing quite a bit on GCP, on Google Cloud Platform, but it doesn't have to be, just so that is said. I mean, this is, I'm going to talk more about the opportunities and everything. Before we do that, let's talk a little bit about pipelines. So what is a pipeline? I mean, we talk about pipelines in different ways. There are like some energy pipelines, there are build pipelines, there are CI/CD pipelines. There are, I don't know, gas pipelines or something. So, it's basically a something that carries something through. And with data, it's pretty much the same. So data pipeline is a directed acyclic graph, probably the best way of thinking about that. So think of it as a conveyor belt, like a typical conveyor belt you see where, I don't know, cars or some other things are put together. You see a lot of like boxes of things arriving in one end. There's a lot of people and machines and things doing things along that conveyor belt, and it goes in one direction. It doesn't just kind of jump back and goes again. So it has a direction, and it has no cycle, so no jumping back and forth. Kind of, it just goes in one direction. And at the end of that conveyor belt, this new shiny car appears at some point. After some work is done. So this is a data pipeline as well. So you have one direction, you do things to that data, and at the end, you get something much more valuable than the original raw data was. Right? How do you build a simple pipeline with Apache Beam? I kind of split it up in 4 different steps. So 4 simple steps to build a very, very super simple, oversimplified probably pipeline, but just to give you an idea. So first, think of an input. So for now, I want you to concentrate on just one part of the input. I'll talk a little bit more about the other parts of it, but for now, just think that our bicycle API is returning us an ID of a station, of this locker thingy where the bicycles are locked into. And it tells you an ID of that. It tells you how many bicycles it has available right there that are for rent. So available, that means you can actually use them. They're not broken. They're not reported being broken. They're not, they're there and they're okay. And there are a number of locks that are totally available. So then you can deduce some information from there, right? You can see if number of bicycles and locks is the same, then you know that that station probably is full. If the locks are there and number of bicycles is 0, so obviously there are no bicycles, and so on, and anything in between, right? So I wanted to go from this, and notice there is no date in here. There is no timestamp for each station. So the way API was a bit kind of unfortunate. It would just give me a huge chunk of data about all stations in the whole city. And there's quite a few of them. I think it was like several hundred of them. And no timestamp. There would be one timestamp all the way down, all the way at the end. And then, you have to parse and process all that. And I wasn't interested in all stations at all time. I would be interested in just the one that is the nearest next to me, right? So I wanted to generate an output of a denormalized, kind of normalized table where I can repeat some information and all those kind of things, but it will be easier for me to do some reporting on it. So I kind of wanted to transform that to a table where I have an ID, we have availability of bicycles and locks, overflow capacity. You can just ignore it for now. It basically means that it's not getting filled up till 100%. There's always a few locks available, so you can actually park your bicycle. So, but don't think about that for now. And timestamp. So when that was the last time that thing was updated. Oh, I actually realized that Mary wrote that Chicago has something called Divey bikes, if I'm pronouncing it correctly. So that's really cool. So that's the same thing, and that's cool. So then you probably have some kind of similar problem.
Yep. Exactly.
And Shyam is writing, what tool did you use for creating Lambda architecture diagram? What was that? I think I used actually Draw.io, I think. If I remember that correctly, I think it was. Let me go back and have a look.
Yes,
I think I used Draw.io because it had like a special plugins for different clouds, so they would actually use the proper icons and everything for the tools and stuff. So I'm pretty sure it was Draw.io. So just kind of cloud service. All right. So to get from here to there, how do I do that? What do I have to do? Well, enter is the first iteration of the pipeline thing. So now it's a very simple pipeline. We're reading files. We're doing input files from the file system. So just basically files. And I was hoarding files badly because I was collecting. So each call to API would result in 2 files. I've shown you one file. I'll also show you the second one, but it resulted in 2 files, and I would pull that data 4 times an hour just because I could, because I wanted to over-engineer the thing. So I would put every 15 minutes, I will pull 2 files, and I will keep on pulling that 24 hours a day. And I have been hoarding that since 2018. So it's been a few years of collecting files. So it's quite a bit of files at some point. And then I wanted to process those from the file system. Well, obviously you have to read them somehow. You have to convert those text lines into something meaningful. So what I did was to map it to a JSON objects with Java, and then I wanted to create a data structure that I actually wanted from them. So basically massage the data, or kind of deal with data and rearrange data the way I wanted from the data structure that I was given. And then I wanted to store the data into the data warehouse of some kind, and well, show it in a table or make it queryable in one way or another. So how did I do that? I'll also explain the Pardue things. If you noticed on the previous slide, there was a mention of the Pardue in the middle box, the box, one of those three boxes in the middle. It says something about Pardue. We'll talk about that in 2 seconds, actually. Yes, not 1, 2 seconds. So 4 steps to create a pipeline. First step would be to create an object for pipeline options, because I mean, it's more of a convenience thing, but there you can pull in and push in a lot of things that you don't want to repeat all the time before when running pipeline. Typically, a path where the files can be found, a thing that how they will be named. What if I do not specify which files to be written and where it has to be, which files has to be read and where they have to be written, and all those kind of things. You put all that into a pipeline options object. And the nice thing of with the whole thing is that you can use annotations in like you would normally do in Java, where you can do like description, you can do a default string and all those things. So if nothing is provided for that option, it will just use the default string, and it will use the description string to visualize it somehow, and so on, so on, so on. So options is a nice thing. It's kind of more towards the nice to have thing, but it's you really want to have that. I mean, otherwise you will be going crazy with specifying all that manually all the time. So that sucks. Then you have to create the pipeline. That is a very, 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 very difficult operation of one line, where you basically say pipeline equals pipeline.create, and you push the options that you've created previously into, or pointer or variable of the options into this object. So then you create a pipeline. That's it. You're done. Now you have to do stuff with it. So now you've set up your conveyor belt, and you've set, how this conveyor belt has to move and where it's going, where it's starting, where it's ending, and all those kind of things. Now you have to start putting things on top of it, and you have to define what to do with those things. So this is where it gets a bit more, this is where the magic happens, actually. So what you basically do is say pipeline.apply and .apply and .apply and .apply, and continue on doing that until you're done with your data. And then you say .apply, dump that thing to a database. So you basically chain those applies, and you can see in this example, it's reading lines. It generates an object and parses that into an object called station metadata, and then it formats stuff as an object, so converts basically JSON to into a Java object that I can play around with, and then it writes that to let me see, what's that? Yeah, that's file system. So text IO, that basically just files and folders and stuff. We'll talk about cloud and things also in a bit. Now back to this Pardue thing that I mentioned. So Pardue, it stands actually for parallel do, and this is element-wise transformations of things. Pardue is a thing that can be processed in parallel without messing up for the other processing, the other processes processing the data. So basically you can start a lot of threads, you can start a lot of even machines doing the same thing without having to wait for the other processes to finish. In this case, that would be like, reading a file and converting that to Java data object or object, and then doing something with that object that can be done. I mean, I can read one file here and one file there and do all these transformations without being dependent on the other things. And then when all that done, I can dump it somewhere. So a typical example of a parallel do in this case, right? The way the parallel do looked for me, and again, I mean, this is probably not the most beautiful code you've seen, but it works. And the idea was to keep it relatively simple without having too much padding and to give you an idea of like what you do with it. So here I use the station data. So I called this data about the station. Well, that thing I called this locker thing I called for station, and then it had some data about station, so station data. And here I would do this extract data from JSON thing, so convert it from text to object, do some stuff with it, and return it. So that was my parallel do. So that's the third step, right? So we're in the third step. We created our pipeline. We created options. We created our pipeline. We created our transformations. We defined these things as a pardo, as a step 3. And now the fourth step would be to run that thing. So since it was Java and it has a Maven plugin and everything for running all that, I use that. So here you can see that, okay, I wanted to run it on my local machine. Well, fine. I can do Maven compile, exec Java, blah, blah. And then I start providing options. So first one is an important thing to notice. It says -p direct runner. Direct runner means that the model I defined in the code, in the Java code that we've seen, can or have to be run on local machine, so on your computer. That is what direct runner stands for. And then you define like main class where it should enter, like entry class for your code and all those kind of things. And then you define arguments. So those arguments that are not provided as default into the options that we saw in the first step, you can define here. So you can say where to find files and everything. And look, this is, for now, since I'm running on my local machine, it's running on the same machine, just different CPUs and stuff. So it will actually create a lot of threads and do all that. So that's really nice with a lot of files, right? Because otherwise, if I would process it in linear manner, it would just take me ages, even with, I don't know, 100 files, and I had thousands of them. And the other thing is that I also would provide pointers to a local file system, so just in folder source. The cool thing with Beam, one of the cool things is that if I had to, and if I wanted to, and at some point I actually had to run it on cloud because I had too many files and I couldn't really process all that on my machine. Because well, I was over-engineering and hoarding data and all those kind of things, and I really wanted to create my own tiny little big data thing. So I ended up being forced to move it to the cloud, and all I had to do, that's a really cool thing, all I had to do is actually to replace a few lines in the Maven options without changing pretty much anything in my pipeline. So my pipeline was a little bit more complicated that I showed you on the screen. I'll show you the real one in some time. I'll link to it. But all in all, I didn't really have to do much else than actually doing this. So I'll go back and forth a few times. So this is on my machine, and this is on the cloud. So as you can see, some options are still there. Some do change. So like instead of direct runner, I'm running Dataflow runner. So the managed version of Apache Beam is called Dataflow on GCP. So that's why it has Dataflow runner. But, still entry class is the same. And then I had to provide some cloud specific stuff like a project name and, which bucket it should look for instead of local file system and, all those kind of things. And the magic thing that it would kind of realize, oh, it's a file system. It's a kind of bucket thing. Oh, cool. I know how to handle that. And I didn't really have to think about that. It just happened that it worked. So that was really nice. And then my pipeline looked something like this. So, this is the drawing that I showed you earlier. And what you could see on that graph, the tiny little graph on the right bottom corner, is that it actually would look at my pipeline, look at the files and say, hey, I see that you have quite a bit of work to do. So I'll spin up a bunch of containers to do those pardos in parallel and to make sure that you're done in just a matter of minutes instead of hours and days just to process those thousands of files. Let's see. Mary is saying someone might not pay enough attention, but can the input be a socket or other type? Yes. So yes, it can be different formats, given that folks contributing to Apache Beam have written connectors to it. So have a look at what kind of connectors they have. They have things for Google Cloud, they have things for AWS, they have things for local things, they have for Spark and all those kind of things. So have a look if they have a connector, and if they don't have a connector, then you can probably request, ask, create a feature request, or create yourself and contribute back. So there are different ways, and they do support different ways of queues. So probably this is what you have in mind as well, Mary. So you think you can also think of like also putting on some kind of queue in the front end, both for feeding data and also taking data out. So the output was like this, right? So now I actually achieved what I wanted. And by the way, Mary, I hope I answered your question. So if I didn't, so feel free to just ask again. I'll do my best. So the first version was like this, right? I had a tiny little bit of data. So it just had 35 megs of data. So much for believing in having full big data storage thing. But I was kind of getting there. I was having 1 million rows, so that was nice. And that was in September 2018. So I was just getting started. But now I wanted to kind of continue my over engineering journey. And now I wanted to, because the IDs of station doesn't make sense just to have IDs for itself. So I had another file, like I said earlier, it was 2 different files, right? So I had another file that would have all the metadata about that station. So that ID can be mapped to ID in the stations that would have geographical coordinates, names, and addresses, and all the magic about it. Even like bounding boxes of how the shape of that station might look and stuff like that. So that was really cool. So then I wanted to do that as well. So of course we're learning stuff, and we're hoarding data, and we're building super big data monstrosity, right? So we wanted to denormalize that thing even further. So now I wanted to put all that information about station into each row, because I didn't want to do merges and joins and everything. And hey, storage is cheap, so why not? And so I did. And the secret probably that I should disclose here is that I really wanted to play around with merging of pipelines and stuff. And that's where we are going now. So the thing is that now I had quite a bit of data. So I had like 600 megs worth of data, which is still just a little bit of data of 2018 and a little bit of 2019. So actually most of 2019, as you can see. And now I wanted to do something fancy. I wanted to do something like this. So I wanted to read and start my 2 different pipelines with 2 different types of files. And I wanted to process them all and do some magic with them. And then at some point, actually do you can call it a join, a merge, and then do some more transformations and actually store it to a data warehouse. So now I wanted to, start reading all the metadata about station and all the availability of bikes and stuff in all stations and join them all together by ID. And I could do that. And now we could do that. We had many more files. We had almost a year worth of files, and we had quite a bit of data. So now it took me a little bit more time to get that processed. So more or less, let me see, it was 14 minutes, so 15 minutes it took me to process the whole thing, but it did spin up quite a few machines. So it was like 150, 160 machines at its worst, and then it would kind of just scale up, process all that, and just scale down again. So now we were getting somewhere. So now we're getting actually quite a bit of data. So now we had, instead of 36 megs of data, we had 1 whole gigabyte of data. Wow, right? Remember I said I didn't want to go enterprise? Well, so much for that. But now we had a few rows as well. So now we went from being I think it was 1 million rows to begin with. Now we had 13 million rows because we had much more historical data. That was nice. And then I kept on collecting that data and kept on processing that data. So last summer, 6 months ago, I did run another batch of processing for whatever data that collected since the last time I processed all that. And then I ended up with even more data. So now I probably have even more, but for now, at that time, I had almost 2 gigs of data, and I had 20 million rows with all the historical data. And processing all of that was it took a little bit of time, but still it wasn't that bad. I mean, it was still just took me like 15 minutes or so, but it would just scale intensely to like lots of machines, like several hundred machines for 15 minutes and then go away. And obviously virtual machines or virtual containers, right? And then I did not think of one thing. And that's probably what you're wondering as well, is the money part. Because, the funny part on the cloud is that, billing does not show up at the second you're done running that. So, but what it actually does, it does give you an indication of increase. So after running my version 2.0, I think it was not for 3.0, I think it was for 2.0, so like 600 megs of data and scaling up to like 160 machines, I got this message in the billing tab of the whole thing. And then I was like, okay, this is going to be bad. So 900% increase in my spend. I had no idea how much it was, but it did show me that it was 900% increase. So then I got a bit nervous, and I think I slept a little bit not really well that night, because I actually had to sleep one night to actually see the real numbers. And the numbers were actually in euros. So you can actually imagine for now, while I'm kind of teasing you, what number is behind the black box, tiny little black box there. 3, 2, 1. Any guesses? Please use the chat. If not, I will be pressing the next button in a second or 2 or 3. Okay, well, I'll do that now. So actually, this huge spike of 200 machines working for 15 minutes and costed me 3.5 euros. That's pretty much a cost of I think like an espresso or something here in Norway. I mean, it's a bit expensive here, but I mean, probably an espresso or 2 in the US as well. It's like, say, $3-4. Not much really, right? But still, I mean, it was like, hey, it was a 900 increase. So basically, I didn't pay anything. And then I had to pay those $4 for that. And this was the distribution of how much it actually costed me. It costed me a tiny little bit of storage because I'm, storing quite a lot of files, but still it's nothing for a month. Less than €1, so less than $1 in storage. That's fine. I didn't pay anything for those gigabytes of data I had in BigQuery. So as long as I wasn't querying them or anything, so it was free. And query as well, this has some limits of like free stuff. So I didn't pay anything for that. All the other things didn't really cost me much. And what actually was the most of the cost were actually those few hundred machines that were spinning up to do the processing. So that was kind of fun. So then I got a bit both surprised and a bit encouraged to play some more and to do some more stuff with it. So that was the original wish, right? And this is what we have implemented so far. And now I talked a lot about batch processing, but I did talk quite a bit in the beginning about the streams as well. So I want to spend a few minutes. I'll be quick. I'll try to be as quick as I can to talk about streams, but I still kind of feel that we should talk about that, since I've been selling it so much to you as a feature. I should probably talk about that as well. So how do we go from batches of files or batch processing in one way or another? It can be just like chunks of data, can be files, can be something. So from pieces of data into a enormous stream of data as like flowing as a water river, whatever, next to you, right? And the problem with streaming is that, well, one problem is that the data is coming all the time. And the other problem is that you have no idea when it will come. So you don't have any specific kind of period. So this is Monday's data, and this is Tuesday's data, and this is Wednesday's data. Well, you don't have that anymore, right? Now you have to live with uncertainty. And the data for 8 o'clock in the morning might actually arrive at 8 o'clock in the morning. That's perfectly fine. It might arrive at 8:30. But then it also can arrive at, I don't know, like 3 p.m., but still data for 8 p.m., 8 a.m., right? 8 in the morning, because, it can be that the user that was sending that data was offline for that during that time, or there was some network problems, or connectivity things, whatever. It can be so many different things. Right? It can be just that the device is scheduled to send data once a day just to save battery and stuff. I don't know, whatever, to save bandwidth. And then you have to think about this general pipelines, and especially with streaming. So what we want to do, and what Apache Beam can help you with, do a few things, especially with streaming. So transformations we talk quite a bit about, right? So just transforming one kind of data into something else. The thing with streams is that we need to think about is the windowing part. So where you actually have to think about data as a windows, and then you can actually get a chunk of data within a specific window, say, I don't know, 1 hour window, or a 5-minute window, or 5 seconds window, and kind of, move that window and have that moving window all the time, and look at what data you have in that little window. Then you need to also look at watermarks and triggers. So you have to look at data, how it's watermarked, and trigger things depending on what kind of data that is and stuff. And you also might think about things like accumulation and everything. So you want to maybe you want to collect data before you process it, and not just process it all the way and just wait until all the 8 o'clock data is, or wait for a big chunk of 8 o'clock data, or whatever. Transformations, that's kind of obvious, right? We can do, not really obvious, that's the wrong word to say, but you get the point. I mean, you can do some similar things that we talked about. You can do element-wise transformation. You can map things, you map all the squares into all the round things, or all the pointy things, and then you're done. You can also aggregate, so you can collect all the squarey things into one chunk, or you can do composite things where you do some magic with all those things, and at the end something else comes out. So all the round and squarey things go in, and hexagons come out. Windowing, like I talked earlier, it can be different ways of windowing, but the point is that you collect data, you put data in chunks based on something. A very typical way of doing that would be time, but it doesn't have to be time. It can be something else. So you basically look at that and put into different buckets, or pieces of data. So again, like I said, it can be time-based, but it can also be session-based. So for example, a game or something like that, that would be, you're more interested in not when the data happened, but who made that action. So who played that game, or who played that thing in the game, or something like that. So then you can actually do it based on sessions instead. And that's a bit different story. Well, okay. So we talked a little bit about streams. So I'm not going to talk too much about streams, but just to give you an idea that you can actually do all that in Apache Beam as well, kind of out of the box as well. So now I want to talk about some cool features that I've seen there that I really liked, and I want to encourage you to have a look at. We talked about windowing, so I want to talk a little bit more about windowing, so to show you that you actually can query data. Let's say here we have 5 minutes every minute. So it's a window that looks at the data worth of 5 minutes, but it moves every minute. So it moves by 1 minute every time the window moves. And this is what you can do. You don't have to write any fancy logic to do that. You just say, well, events apply, and then you say sliding windows of 5 minutes every 1 minute. That's it, done. and it will be giving you that data every minute. Another really cool thing that is a partly shameless plug and partly a bit of a frustration that I wanted to share was that when I was running it locally, I had no idea how my pipeline actually looked, because when I was running it on a cloud, as you've seen earlier, I'll go back, way back, and then show you this, just what I mean. So this thing that you see there with little boxes with the green little things on top that you see on the left, really, really nice visualization on the cloud. But on your machine, there was nothing like that. And that kind of really bothered me, really sucked. And I had to kind of, always to debug things. It was a bit annoying. So I wanted to do something about it. And I did. I've been digging into documentation, into mailing lists, into like all these things, and asking people how can I get the visualization representation of the graph. And then I realized after a little bit of digging that you can actually do it in a very simple way. You just you export this thing into a dot string, so dot format. A representation format for graphs, and then you can use your favorite tool, whatever that might be, to visualize it. So I wrote a tiny little blog post about that at some point earlier. So you might want to have a look at that, but you can also you can export this dot file into something else and create much more pretty version of what you can see up there. It's not the prettiest thing I've created, like with the boxes and arrows and stuff. So the other cool thing was that it was very easy to switch from reading and storing things into files to actually reading from buckets and stuff, and also storing it into a database. So what I ended up doing, I put all that into BigQuery, which is like the managed, serverless data warehouse solution that we have on the cloud. So I put that thing into a BigQuery, and I would store all that millions of rows of data there, because it's, I don't have to think of backups. It really returns me really fast the output and everything, right? So that's really nice. Oh, thanks, Mary, for sharing the link. That's really nice. So switching between file storage, storing into files to a database was quite easy. It didn't really have to be too much work. I had to define schema and things like that, like you would typically do for a table in database, and that was pretty much it. And then map it, and that was it. So in a code, it looked something like this. So like last two lines, if you look at them, so apply map elements, blah, blah, into text, and then you do text.io.write. So you write to a file name. I replaced those two lines with a different transformation where I map things into a thing storing to BigQuery and then writing things to BigQuery. So those two applies were replaced by two other applies. Last apply is a bit chunkier than the previous one, obviously, but if you store it into a file, you don't have to define schema and everything, and you have to with the database. So you're not getting away with that much. But the cool thing is that it actually looks at the structure, and if the structure is not there, it will just create one for you and then start storing things. If you just have a table already, you might not need that much padding in a way. The other cool thing was that I could just redirect all this data pipeline into another output and actually push it into another database, because a colleague of mine, he's a big fan of this another open source tool called ArangoDB, which would do some cool things out of the box. So he just like, hey, give me the stream of data, and I gave him, and then he put into his container with ArangoDB, and then seconds later we had this solution of map, which apparently ArangoDB creates out of the box, and then you can actually look at the geographical data about stations, which show it on I think it's OpenStreetMap leaflets solution, and just it would give you some buttons and things out of the box. So that was kind of fun. And like I said, you have quite a lot of data, and you can actually process that data, and you can do some fun things with it. So this is an example of a query I had. For a specific station, so specific one of those stops. and also showing availability of broken bikes, so bikes that are not usable, because you can calculate that, because if you look at this thing and you see that the total availability of the station is, say, 10 bicycles, and there are 5 bicycles available. So then you know that there should be five locks available. And if you don't see 5 locks available, if you see anything less than 5 locks there available, then you know that there must be some bicycles parked there marked as broken. So if you see just 2 left, 2 open spots left, then you have to know that, okay, we have 5 bicycles ready to be rented, and we have 2 spots to put bicycles. What happened to the other 3, since we have 10 in total? And those 3 would be broken bicycles, right? Or broken locks. So you can actually calculate things from that, right? And then you can also see based on month, day of week, and hour. So you can see that, well, you know, on Saturdays at 9 o'clock, this is a station very close to the university here in Oslo. So, you know that probably students will not be at the university at early Sunday morning or Saturday morning. So let's check if that idea, if that theory holds, right? So you can look at the data and there's like, yeah, well, you know, there are almost full of bicycle stations, no broken bicycles, no nothing. It's really nice. And then you see on Mondays, just like plummets all the way down. And that's really cool. So now you could actually, with 20 million of data, rows of data, you can actually do this kind of things. You can do trends. You can do things that I showed you in the beginning, where you can actually see the trends, like if it's upward going or downwards going trends and things like that. That was kind of cool. And then you got another moment of, you know, amazed monkey moment, I call it, because of that picture. But, you know, where you're just like, oh, wow, this is really cool. I mean, I went from nothing with lots of nerding and stuff and into pretty much like, you know, my own little big data project. That was fun. A few things that I want to, like at the end, I want to mention as a warning, and that is that your pipelines look beautiful and they're portable and they're fantastic and they're awesome and everything, but they might and they probably will break at some point. So you will end up making sure that your pipeline is actually, you know, robust and works well with if data changes. So what happened, like just to give an example, was that at some point I could see the data arriving to my storage, and I could see that the JSON files that they would give me were kind of regular, like you expect from a web service, a JSON, where they're all squished together, not human readable, but more like, you know, just save data, save space and make it easier. So all in one line, just like one big ugly JSON object, just machine readable and everything. At some point, what happened was that that service went down. It gave me a lot of 500 errors for some time, and then it would just came back with pretty printed machine readable version of that, and that really sucked, and it broke my pipeline. So I had to do some things and everything. So just a word of advice: just make sure that your pipeline is robust, and you will probably end up doing things over and over again, making sure that it is it has to be robust and not break. So all the code that you've seen there, and quite a bit more, and some example data and everything, it's all open source. So put it all on GitHub, so you can find it there. It's feel free to play around with it, and you know, if there is anything, feel free to ping me, and I'll be happy to both explain and show. And I, from time to time, I do run the updates of the whole package and everything. So updating libraries and everything, making sure it all runs, just as a way of making sure that the whole thing is reproducible. So this is me on Twitter. Feel free to ping me. This is my email as well. So feel free to ping me as well. I'll be happy to answer any questions if there are any now. And I think that will be it. So I hope you learned something. I hope you get inspired to try out some new stuff that you haven't tried. And I hope you get inspired to solve your own problems with your own magic powers. Thank you very much.